Now, the reason that this is so easy is that this is the first of many equations that you're going to see like this. That's going to be the following. The heat of reaction that you're going to get for a reaction is going to be equal to the sum of the heats of formation of the products minus the sum of the heats of formation of the reactants. Now, please remember from the lecture video, this is backwards to bond energy. Remember that if you're going to do heat of reaction for the bonds, then the bonds is the sum of the bonds of the reactants minus the sum of the bonds of the products that are there. Why? The reason it has all to do with signage. Remember that for bonds, all numbers are positive. If you look here at the bond energies here on this chart, every single one of these numbers is positive. And because every single one of these numbers is positive, we are going to assign positive or negative based upon whether or not it's being broken or formed. Consequently, the math on it turns out to be reactants minus products. But because heat of formation values can be positive, negative, or zero, then we could end up with those guys there being, again, positive, negative, or zero. It will work like a normal delta, because remember, a normal delta is final minus initial. That is there. So final minus initial, or products minus the reactants. That's the way almost everything is always going to work on these problems. Final minus initial, products minus reactants. It's just that that first one with bond energies is a little goofy. So what have we got here? Well, all we have to do is look up the values for each of these guys, and I have done so for you already. This guy is a negative 46. That's a 0 because it's an element in its standard state. That guy is 90, and that guy is negative 242. So consequently, all I have to do is add up all of the products, which are these guys, and then subtract from that the reactants, which are going to be these guys over here. So what am I going to get? I'm going to get in blue over here 4 90s, because again, that 90 is for one of them, and I have 4 of them. And then I'm going to add to that 6 negative 242s. That's going to be your products. And then I'm going to subtract from that your reactants here. So that's going to get subtracted for your reactants. And that's going to be 4 times negative 46, and then a whole bunch of zeros. So all of that added together, if you do all the math on that, assuming I have done my math correctly, is negative 908.